Greetings to our lecturer for Nursia. My name is Yaamini, metric number 272372. Today, our group is going to present on the project of application of partial derivative in engineering and economics model. First and foremost, before I begin the presentation, I would like to do introduction of my team members. Lim Zheng Chung, metric number 270181. Kelly Neo Kai Thi, metric number 271560. Kanchana Mahendran 272897 and Nur Shafikah binti Abdullah, metric number 273296. Now I will start with the background of study of this project. Partial derivative is involved in any calculus-based optimization problem with more than one option variable. Moreover, it is also likely to say differentiating one of the variables while keep the other variable fixed. Next, at origin, in year 1770, Marquis de Condorcet introduced the use of mathematical symbol, which is used for partial derivatives. Then, in the year 1786, Adrian Mary Legendre created the model partial derivative notation, in which it was abandoned in later year and reintroduced the symbol in year 1841 by Carl Gustav Jacob Jacobi. Thus, in later years, partial derivative has become widely known in application of real world, in which it is commonly used in application problems of engineering and economics. Next, I will pass to my team members to continue present more detail on how the application problem are solved.
The objective is to study of the finding derivatives of functions of multivariable plays a major role in wide variety of application model problems in mathematics, science and engineering as differentiation of single variable function. Second is to study and analyze about the higher order partial derivatives, which is Clairaut's theorem. And the third one is to study and analyze on how to determine whether the products have a positive or negative marginal utility and prove that the law of diminishing marginal utility is true. And the key concept is, first of all, the law of demand states that other factors being constant, which is ceteris paribus, price and quantity demand of any good and service are inversely related to each another. For instance, when the price of the product increases and the demand for the product same will fall. Next is, in mathematics, the symmetry of second derivatives is also called the equality of mixed partial, refers to the possibility under certain conditions of interchanging the order of taking partial derivatives of a function of n variables. One of the theorems were used in this, which is Clairaut's theorem. Next is Clairaut's theorem. Characteristics is the surface gravity on a viscous rotating ellipsoid in equilibrium under the action of its gravitational field and conformation force. It was initially used to relate the gravity at any point on the Earth's surface to the position of that point, allowing the elasticity of the Earth to be calculated from measurements of gravity at different latitudes.
Good morning, everyone. Now I would like to discuss the methodology of our assignment. The methodology of our assignment will be focused on partial derivative of two variables. Let f equal to 2a cubed b squared. So according to partial derivative, we can differentiate the equation partially in two ways. First, we can differentiate the equation f with respect to a and regards b as a constant. Hence, the result will be the 6a squared b squared. The formal definition of partial derivative with respect to a is f differentiate with respect to a is equal to limit where h approach infinity, f a plus h, comma b minus f a b divided by h. Secondly, we also can differentiate the equation f with respect to b and regards a as a constant. Hence, the result will become 4a cubed b. The formal definition of partial derivative with respect to b is f differentiate with respect to b is equal to limit where h approach infinity, f a, comma b plus h minus f a b divided by h. The first order partial derivative can be represented by many notations. So here is for this column, this is the notation for the f that is differentiate with respect to a, and for this column, this is for the function that is differentiate with respect to b. Now let's talk about the second order partial derivative of the function. So from the calculation before, we found out that the f differentiated with respect to a is equal to 6a squared b squared, while for the f that is differentiated with respect to b is equal to 4a cubed b. So there are four options from first order partial derivative to become second order partial derivative. First, the f differentiate with respect to a is continue to differentiate with respect to a, so b as a constant. Hence, the answer will become 12ab squared. Secondly, the f differentiate with respect to a is now differentiate with respect to b. So now the a as a constant. The answer of this calculate partial derivative will become 12a squared b. The third option is when the f that is differentiate with respect to b is now differentiate with respect to a. So now the b is become a constant. So the answer of this calculation will become 12a squared b. And the last option is the f that is differentiate with respect to b is continue to differentiate with respect to b. A continue to become a constant. So the answer of this calculation will become 4a cubed. So now we can also there is many notation that can represent the second order partial derivative. So for the first column is the notation for the function that is differentiate with respect to a twice. So for second column is the function that is differentiated with respect to a and then differentiated with b. So for third function, for third column is the function that is differentiated with b twice. So for the last column is for the function that is differentiated with respect to b and then with a. So from the calculation above, we can observe that the f that is differentiated with a and b is equal to the function that is differentiated with respect to b and a. So this is because of the Clairaut theorem. So according to Clairaut theorem, if f is defined on a disk D that contains the point xy, so if the function f differentiated with x and y and the function differentiated with y and x are continuous on this disk, then the function of f differentiated with x and y is equal to the function that's differentiated with y and x. So that's all from me. Thank you.
I will explain about the example and analysis 1. In economics, marginal utility can be known as additional satisfaction that a consumer obtains from having additional unit of goods and services. Positive marginal utility means that the total utility increase when additional of goods or services is purchased, while negative marginal utility means that the total utility decrease when additional unit of goods or services purchased. Law of diminishing marginal utility can be defined as the amount consumed increase, the marginal utility obtained from consuming equal unit of goods and services decrease. How do we determine whether the product have a positive or negative marginal utility and prove that the law of diminishing marginal utility is true? For question 1a, for good one, we need to differentiate the equation of u with respect to x and regard y as a constant. Thus, we can conclude that mu1 is 1 minus alpha, x power of negative alpha, y power of alpha, and means that positive marginal utility is occur when having more of an item bring additional happiness. For goods too, we also need to differentiate the equation of u with respect to y and regards x as a constant. Thus, we can conclude that mu2 is alpha x power of 1 minus alpha, y alpha minus 1, and means that positive marginal utility is occur when having more of an item bring additional happiness. For question 1b, for good one, we need to find the second partial derivative of equation u with respect to x and regard y as a constant. Since second partial derivative is less than 0, therefore phenomena of diminishing marginal utilities for good one is persist. For good 2, we also need to find second partial derivative of the equation with respect to y and regards x as a constant. Since second partial derivative less than 0, therefore phenomena of diminishing marginal utilities for good 2 is also persist.
So for the second example, in engineering and construction, it is always important to know the volume of building for a variety of purpose. It is unavoidable that the error will exist when calculate the volume of the building. Hence, how do we estimate the maximum percentage of error given the error in finding height? So beside the dimension of the building is always not constant as there is many variables in constructing the building. So it's also important to determine the rate of change of the dimension of the building to estimate the effect of changing of dimension towards the building. So for example 2, we were given that the Sabah Foundation building as an example, which is a cylindrical building to explore the partial derivative with two variables. The question given that the height of building is 122 meter and its circumference is 140 meter.
So the equation of volume is given by V equal to pi r square h. The question asks for to estimate the volume of cylindrical building and the maximum percentage error of volume in part 1, and also determine the rate of change of volume of building with respect to the height and radius, and also prove that whether the rate of change of volume of building with respect to height is absolutely maximum or minimum. So the question A, to find the volume of the cylindrical building, we have the information of circumference and the height of building. So to find the radius of building, we can get the R is equal to 70 over pi, and then we get the volume is equal to 190285.65 m cube. So to calculate the percentage of error in volume, we need to calculate the error of calculation for the volume. So we start to differentiate the volume with respect R and also differentiate the volume with respect H. So after total these two, we can get the approximated measurement of V, and then we will get the maximum percentage for the volume estimated is equal to 0.4898%. So to find the rate of change or volume of building with respect R, we can use the theorem of first partial derivative. So from there we can get 2 pi r h, and substitute the h equal to 122 and the r is equal to 17 over pi, and we'll get 17080. So from this value we can conclude that the rate of change or volume with respect to R is maximum since the value is bigger than 0. So to find the rate of change of volume of building with respect h, we also can use the same method, and we can get pi r squared. So when r is equal to 70 over pi, we will get 1559.72. So this value we can conclude that the rate of change of volume with respect to h is maximum since the value is bigger than 0. So from D, to determine whether the height of building is absolutely maximum or minimum, we need to apply the method of second partial derivative. So after this, we can get 2 by h. So since the value is bigger than 0, so we can conclude that the height of building is absolutely maximum.
In a conclusions, there are a lot of application of partial derivative in real life. In this project, we focus on application in economic and engineering, but using partial derivative, there are still a lot of application that we can use in real life, such as in business and finance. We hope more people can learn about partial derivatives so that it can be an advantage for them. Here in our project, we have shown that the importance of learning and apply partial derivative by using example 1 and example 2.